Hi, Algebra 2. This is Unit 2, Lesson 4, and today we're going to talk about the domain and range of a function. So the domain is the inputs. It's a set of all the x values. So it's a set of all the x values. It's my inputs. And the range is the set of all the y values, which are my outputs. Okay. So just to review with you different ways that we can write the domain and the range. We can write it in roster formation, which means that I'm listing all the elements. So you would do this if there was a finite set of elements that you were putting in. Like if I had just 1, 2, 3, 4, 5. If you had a whole lot of elements, you wouldn't want to write it like that. Set builder notation, x such that x is greater than 0. So basically any number greater than 0 would be the domain or range. An interval notation, this is the easiest. This is my favorite way to do it. Say I wanted all the numbers between -2 and 5. So I would write -2, 5. Now, if I don't want to include -2, I put a parenthesis. If I wanted to include 5, I would put a bracket. So just to translate what that means right there, basically I'm including the 5, but I'm not including the -2. So this means this. Okay, but you're just using parentheses and brackets around the two numbers that you have. So basically, again, my domain or that's my input. And my domain usually could be practically anything. It's the output, the range that's restricted by the numbers that you're putting into the domain. But sometimes I am restricted or limited with the numbers that I can use in the domain. So there are 3 cases to look for restricted domains. Rational functions. The denominator cannot equal 0. So if you have a fraction, the denominator cannot equal 0. That's the first one. The second time we might be restricted with a square root. The number inside has to be greater than or equal to 0 because I can't have a negative under a square root. And a square root in the denominator. So I have 2 restrictions. It has to be greater than or equal to 0 for square root, but I can't be equal to 0 if the square root's in the denominator. So in the denominator, I take it and I set it set the inside of it, what's under the square root, to greater than 0, and you solve for the variable, and that will give you your restrictions. So these are the 3 restrictions, and I'm telling you what to do for each restriction. So if it's a rational function, take the denominator and set it equal to 0, that's not allowed to be equal to 0. So that would be a restriction. If it's a square root, take what's inside or what's under the square root, set it equal to greater than or equal to 0, and solve for the variable. And if it's a square root in the denominator, set the inside greater than 0 and solve for that variable. So let's look at example 1. So I have a fractional or rational number. The denominator cannot be equal to 0. Can't equal 0. So I'm going to take this denominator, and to figure out what my domain can't be, I'm going to take that x plus 1 and I'm going to set it equal to 0 and solve. So basically the only thing that x cannot be is equal to -1. So my domain can be anything except it cannot be equal to -1. So that's my restriction right there. Right. Second one, I have a second case, so I'm looking up here for square root. So with a square root, the number under the radical must be greater than or equal to 0. So I'm going to take that number, that expression under the radical, and set it equal to greater than or equal to 0. I'm going to solve for x. So basically any value of x that's greater than or equal to 0 will work. Greater than or equal to 5, sorry. Okay, so that's my domain right there. is that x is greater than or equal to 5. Just think about it. If I put 5 in here, 5 minus 5 is 0. That's great. If I put 10 in here, 10 minus 5 is great, that's okay. What if I was to put like a number like 1? Well, 1 minus 5 is negative 4. You can't have the square root of negative 4. It's not allowed. So that's what I'm doing when I'm trying to figure out this domain here. And the third case is when I have a radical in the denominator. So if that's the case, the number under the radical can't be negative, and the denominator can't be equal to 0. So I'm going to take that x plus 3 and I'm just going to set it equal to greater than 0. So then I'm subtracting, and I have x must be greater than or greater than negative 3. So that's my domain. My domain is all the numbers such that x is greater than negative 3. Okay, it can't be negative 3 because negative 3 plus 3 is 0. I can't have 0 in the denominator. But it can be anything greater than negative 3. So negative 2 works, negative 1 works, 0, 1, 2, 3, 4. But a number like negative 5 wouldn't work because negative 5 plus 3 is negative 2, and I can't have a negative under that denominator. Okay, let's look at some graphs. All right, determine the domain and range of the following graphs. So basically, my domain is my x's. So when I'm looking at my domain, it's my x. I'm looking left, right. So if I look at my graph right here, look to the right. What's the highest x value I have? Well, look at this arrow. That means I keep on going. I'm going in the direction of the right, up and up and up forever and ever. So I'm basically, it's for till infinity. Look at left. What's the smallest x value I have? Because my domain are my x's. So I'm looking at the x's right here. This arrow is implying that I'm keeping on going to the left forever and ever and ever. So my domain to the left is negative infinity because it's never, ever, ever going to end. So basically, it is from negative infinity to positive infinity. If you want to write it in the interval notation, I can write it like this. Now, one thing to mention when I'm talking about infinity, I use parentheses. You're never going to use brackets. All right? Now, my range are my y's. So let's look at my y's. So my highest, let me change the color here for us. My highest y value, again, I have that arrow. These arrows are saying that it's going to go forever and ever. So my highest y value is infinity. Now let's look at my lowest y value. Well, my lowest y value is right here at 0. So my range is a little bit different. My range includes 0, and it goes all the way, oops, I didn't mean to write 8 right there. It goes to infinity. All right, again, if I want to use my interval notation, I'm including the 0, so I'm going to use a bracket, and then it goes to infinity. Infinity, I'm always using parentheses. Okay, so the left, right, and down and up, that's just to help us as we're trying to figure this out in the beginning. So if we're looking at my domain, my x's, okay, look to the right, look to the left. The lowest x value, well, it never ends. It keeps on going on because I have that arrow right there. My highest x value to the right, it never ends. It keeps on going on. So it's going to be the same as that example 2 above. Now my range are my x and are my y's. I want my lowest y value right here. Now this one's a little tricky because it's actually going below negative 2. So I don't know exactly what it is. And then I want my highest. So my highest, that arrow is going forever and ever and ever. So my highest y value is infinity, and it looks a little bit more than negative 2. So I'm going to write negative 2.2. And we'll have ones, if you ever had a test or anything, that were exact, so you wouldn't have to estimate that. All right, so example 2 and example 3 were similar to each other. Let's look at example 4. It's going to be a little bit different. So again, my domain or my x's, the highest x value right here is 3. And then I'm looking to the right, to the left, my lowest x value is negative 3. right? So left, right is my domain. Those are my x's. The lowest value is 3, -3, and the highest value is +3. I'm including those numbers, so I will use the brackets. Now when I'm looking at my range, those are my y's. So I want my most lowest y value and then my highest y value. And again, that's -3 and +3. I am including them, so I will use brackets. Example 5. So now my domain, I'm looking left, right. So this is up, that goes forever and ever, that's infinity. I look to the left, look at my arrow, I'm going forever and ever, that's infinity, so infinities are easy. And then I'm looking for my range, those are my y's. Look up, there's no highest y value, it keeps on going. Even though it's all the way down here, that arrow is going to the right and it's also going up at the same time. And the same thing for down, there's no lowest y value. This arrow, even though it's up here, is going to the left, but it's also gradually going down. So it's going to, my range will also be -infinity and +infinity. Again, with the infinity, I'm just using those parentheses. I am not using brackets. All right, example 6. The function x squared minus 2x minus 3 is graphed on the grid below. Which of the following represents its domain and range written in interval notation? All right, so domain. Domain are my x's. My domain is going to go to the right and it's going to go to the left. Is there an ending or highest value that x ends at? No. Is there a lowest value that x ends at? No. So my domain are going to be my -infinity and +infinity. Range. Is there a lowest y value? So I'm looking down. Yes, there is. 1, 2, 3, -4. Highest y value? No. So it's going to be -4. I am including -4, but there is no highest y value. So that would be choice 3 right here. Which of the following values of x would not be in the domain of the function y equals x plus 4? So remember, when I have a radical, you can't have a negative under the radical. Okay, so I'm going to take that expression under the radical, x plus 4, and set it equal to greater than or equal to 0. It's okay if it's 0, but it cannot be less than, it can't be negative. And I'm just going to solve for x. So x is greater than or equal to -4. So I'm looking for which of the following values would not be in the domain. I'm looking for something not in the domain. So any number that's greater than or equal to -4 is okay. Is 0 greater than or equal to -4? It sure is. Is 5 greater than or equal to -4? Sure is. Is -3 greater than or equal to -4? Sure is. Is -8 greater than or equal to -4? Nope. So that's my answer. The function f of x equals 2x plus 1 over x minus 4 has outputs given by the following calculator table. Evaluate f of 1 and f of 6. All right, so f of 1, I'm going to come right here. F of 1 is -1. F of 6 is right there. So f of 1 equals -1. F of 6 equals 6.5. Why does the calculator give an error at x equals 4? It gives an error at x equals 4. Look at up here. If x was equal to 4, 4 minus 4 is 0. Okay? Because if x equals 4, the denominator would equal 0, and you can't divide by 0. So it's not allowed. The denominator is not allowed to equal 0. If x was 4, that would make that, if you replaced x right here, that would make that denominator equal to 0. Are there any values except x equals 4 that are not in the domain of f? Explain. No, there are no other values of x which when substituted into the function as inputs would force the function to divide by 0. So no, there are no other values that would make denominator equal to 0. So that's the only thing I'm concerned with right here, is if the denominator was equal to 0. That's the only thing that's not allowed to happen. Okay, flip this over. I just have a few more on the next page. So for 9, I'm going to state the domain and range of each using set builder notation. I actually just did my interval notation. I'm looking at my notes right here, but we'll do set builder notation. So basically, remember my domain is my left, right. So the highest x value is 4. The lowest x value is -4. I am including them, so this would be my interval notation. So this is my domain. I should write that down. Domain. Okay, and otherwise I'm writing x such that, and then I'm going to include my -4, and I'm going to include my 4. Okay, and then my range. The lowest y value is -2, and the highest y value is +2, because my range I'm looking up and down. So again, if it was an interval notation, which is a lot easier to do, otherwise x, such that x is going to be between -2 and 2. I am including them, so I do have my equal signs there. B is a little bit tricky. So my domain are my x's, but I have two different domains. So I have this right here. This is the leftmost value. So the smallest value in my domain is -3. Here at 0, neither of these lines are at 0. Okay, so I'm not including the 0. But I am including the -3. Okay, and I have another domain from here, as long as x is greater than 0. So again, I'm not including the 0. But I'm going to go look at the arrow at the end of this. I'm going forever and ever. So I will have that one be infinity. And then my range are my y's. So the highest y value is, look up, it goes forever and ever. So that's going to be infinity. And my lowest y value, I'm not including this -3, but it's anything that's bigger than -3. Okay, so that's my domain and my range. Same thing on 10. I'm just stating my domain and my range. So remember, my domain is left to right. The leftmost value is going to be -3. And my rightmost value is right here at 4. I am including those numbers. My range are my y's, that's my up and my down. The lowest y value is right here at -4. And the highest y value is right here, again at +4. Looking at B, my domain, my x's go left, right. The lowest x value is 0. I am including 0, so I'm going to use a bracket. My highest x value, look, there's an arrow there, so that's going to go to infinity. And then my range are my y values. My lowest y value is right here at 3. I am including the 3. My highest y value is, I look up, there's no upper y value. This arrow, even though it's going gradual, it's going to the right and up, so that is going to be infinity. State the domain using interval notation. So basically, I have a fraction right here. With a fraction, the denominator can't equal 0. So I'm going to take this denominator, set it equal to 0, and solve. So basically, it cannot be -1. So look how I'm going to write this. It can be negative infinity all the way up to -1, but not including the 1. Or it could be from -1 all the way up to positive infinity. So including every number but the -1. So I can't write this because I don't want to include the -1. So I write from negative infinity to -1, not including the -1 with the parenthesis, and then I write from -1 to positive infinity, again not including the -1. All right. Next one right here. I have a radical. With a radical, you can't have a negative under the radical. So I'm just going to take just what's under the radical, okay, just this expression right here, and I'm going to set it to greater than equal to 0. It's okay if it's 0, but I'm going to have to make it greater than or equal to 0. So as long as x is greater than or equal to 2. So 2 I'm including, and then any number that's bigger than that, so I will go until infinity. Okay, so try the homework problems that go along with lesson 4, and then,